Westerfield, and I'm with Curtis Mathis Grow Lights. And today we are going to be exploring everything you wanted to know about growing plants with lights. There's a lot of stuff to be talking about. It's going to be on the technical side. So get something to drink and we're going to dive in. When So let me just go ahead and we'll start. I'm going to introduce Bob Manis. And Bob, would you tell us about yourself again?
Yeah, hi. I'm the president and chief operating officer of Curtis Mathis Grow Lights.
And we have Zach Hildenbrand, also of Curtis Mathis Grow Lights. Zach?
Hello, yeah, I'm the Chief Scientific Officer of Curtis Mathis Grow Lights and a research professor at the University of Texas at El Paso.
Okay, one of the things that we're going to be talking about is the difference between growing outdoors and a greenhouse and a controlled environment agriculture. And the thing that we're going to be focusing on is controlled environment agriculture. And
Sure.
So we'll start there, talk about some of the basics of what's going on inside the plants, and then how Bob over with his genius has come up with ways to take maximum advantage of all the things going on inside the plant. So Zach, what can you start off and tell us about what's going on inside the leaf of a plant?
Well, first I'd like to start with the outdoor stuff and talk about the differences indoor versus greenhouse versus outdoor cannabis. So, of course, if you've seen our last episode, a lot of the lighting and lighting technologies out there are essentially trying to emulate the sun as best they can through the well-established science of what's called the McCree curve, where essentially you're trying to capture the spectrum of light within a photosynthetic range, albeit with indoor settings, you're able to really augment the intensities. Outdoor cannabis is fantastic. You have the sun. Your cost per production is super low. There's certainly an environmental aspect to that, which is very nice. However, it's not controlled environment agriculture. You have to deal with the elements, humidity, temperature, biblical plagues of locusts, hailstorms, freezes, and one aspect that most people don't talk about, which is pollination. And this has been a particularly prevalent issue both in the cannabis and hemp sectors, where you're growing these wonderful feminized plants. And let's say you're in the cannabis space, and then you're next to a hemp grow. And then that hemp pollen gets into your cannabis grow. And then now you're these kind of hybrid, if you will, seeds. And so anytime plants outdoors get seeded, the quality of that as a commodity is greatly reduced. You pull that indoors, and of course, with greenhouses, you get the benefit of having free sunlight, and you're able to control the setting much better than outdoor. And then with the addition of supplemental lighting, such as full spectrum LEDs, you're actually able to emulate the quality that you can produce indoors quite well for a fraction of the cost. Of course, we bring it all indoors. And then, of course, we can dial in temperature, humidity, lighting, photon density, all of these things. We can get them dialed in as a well-oiled machine. However, in the indoor setting, now this is where your cost goes up considerably, and you're likely using more lights, which means there can be some environmental implications of that in the sense of how much waste heat is being produced, how much electricity is being utilized, and how much CO2. This is certainly a metric that people are becoming more cognizant of. Is what is my carbon footprint for this particular grow? So that's just a very superficial look at the indoor versus outdoor versus greenhouse. There's a lot to consider.
But do you also not avoid the heavy metals, because that's become an issue here in Arizona when they're growing, especially up the high country?
Yeah, so right there, Arizona is particularly bad because they have really poor groundwater. It's loaded with a lot of arsenic, a lot of other heavy metals, barium, strontium, selenium as well. And so the one thing that's kind of a double-edged sword with cannabis and hemp is this plant's very effective at what's called phytoremediation, in which it's able to uptake a lot of those metals from the soil. And of course, then you're storing it in the vegetative matter. So Some folks can be like, well, it doesn't matter what my soil quality is, doesn't matter what the groundwater quality is here. I'm just going to use this to be as cheap as I possibly can in terms of cost effectiveness. But that could really bite you in the behind at the very end there, because as you go in for your compliance testing, heavy metals is one of the classes of compounds you need to test for. And if you blow hot, then your product is essentially worthless. So that's where, again, bringing it indoors with controlled environmental agriculture, you can control soil quality, you can control water quality, you can control all of these parameters to a much greater extent than you can in the outdoor setting.
Well, excellent. So Bob, where do you go from there? I mean, why LED lights and not high pressure sodium or metal halide?
Well, high pressure sodium, as you all know, is the prominent solution, indoor lighting solution for cannabis, has been for quite some time. Thankfully, that's switching over to LEDs. And the reason it's switching over to LEDs are some obvious issues: heat. HPS lighting, an HPS lamp can generate as much as 700 degrees Fahrenheit and quite a bit of waste heat. The envelope or the lamp in an HPS is generally somewhere in the neighborhood of 5 to 10% efficient. So everything else is being produced as heat, which you have to take care of. And in a controlled environment agricultural solution, that's HVAC and power, as Zach just alluded to. LEDs, especially as they become cheaper, LEDs are providing a cost-effective means to create a spectrum, a very specific spectrum, custom tailored to whatever you're growing, and in this case, of course, cannabis. In addition, LEDs allow you to control your output, whereas with the high pressure sodium, the output is controlled usually by a reflector or a hood of some sort, which we're all familiar with. But that reflector poses quite a few problems. There's luminaire bounce, which is a lighting engineering term for the light bouncing around inside and being canceled out within the reflector. There's also direct cancellation. Well, when you take a light source and you reflect it right back at itself, and if it happens to be at the correct distance, it'll actually cancel it out up to 100% for that particular photon stream. So well, with LEDs, it's directional in nature, and you can lens them, and we have lenses called total internal reflective lenses that will actually collect every bit of light minus, well, there's a little bit of loss, 6 or 7% in the materials itself, but then the rest of the light is actually put exactly where you want it to go, and it's determined by the beam angle of the lens, and these come in all kinds of flavors between 120 degrees output, 90 degrees output, down to, I've seen 3-degree lenses. I don't use them, but I've seen them. So, and it's an extremely controllable indoor lighting solution in LEDs. And as the LEDs become cheaper, and of course the materials change such that the lifetime is extended. We're looking at LEDs right now that will service your grow well for 10 years at a time.
Now, one of the things I've read recently is there's a phenomenon called peaking, where the plants grow best directly under the high pressure sodium or the metal halide lights, and that doesn't occur with LEDs. Why is that?
I'm sorry, I'm getting some feedback. So as far as peaking goes, well, with high pressure sodium, if you're familiar with the technology, there's a lamp or a bulb inside a hood, and that bulb represents a single point source of light. So you've got what appears to be this giant flashlight shining down on your plants, but it's not really. It's actually only a light source that is only a couple of millimeters wide and a couple of millimeters long. And that when you're looking at the direct light from a high pressure sodium coming down on the plants, of course, it's going to be strongest directly over the plants. And as you move out to the fringes of your crop, the distance becomes further and further, and light has a tendency to drop off dramatically as you increase the distance. It's called the inverse square properties of light. And what that basically says is that every time you double the distance from a source to a target when you're using light, it decreases the photon count or the output by 75%. So you could be, if you're, and I want to use my hands here, but I want to have a visual aid, but LEDs allow you to use multiple point sources of light and spread them out over your crop and get better distribution. And that spread allows you to minimize the peaking effect that you generally see with high pressure sodium.
Well, that sort of leads into, my next question is what's the difference between efficiency and efficacy of the lights? It sounds like you're saying that LEDs are better at both.
Yeah. From a lighting perspective, efficiency and efficacy are actually two different things. Efficiencies also take into account the efficiencies of the power supply, how much power you're getting out versus power you get in, what the actual losses are thermally. LEDs the same way. You're getting efficiency is heat loss. Efficiency in the luminaire itself. So our lenses contribute to a loss of efficiency. Reflectors contribute to a loss of efficiency. As far as efficacy is in pure lighting terms, and this is a pet of mine, is are the metrics that are used and slung around out in the field for efficacy for cannabis lighting or any agricultural lighting, is the actual number of lumens per watt that are produced by a device. If you go to a laboratory, you generally send your luminaire into the or the light into the laboratory, and you say, I want you to test this and tell me what I get out of it. Well, you can send it in with lenses, you can send it in without lenses, you can send it in with a different power supply. You really, when you get these results and you see some of the marketing, you're really not sure exactly how they tested it. And so
you're saying you can manipulate and get pretty much what you want.
You can, to an extent, yeah, as long as you're not dealing in junk.
And I think also what Bob is saying is that there's certainly this desire for everyone to distill the efficacy of their lighting technology down to one metric. And then, of course, so if we distill this down to one metric, and I say that my light is X, well, then the guy next to me is going to say, well, mine is 2X. And then the next guy is going to say, well, mine's 2.5X, right? And so it's really not that simple. You have to account for spectrum. You have to account for photon delivery, and all of these other aspects, such as the cancellation, the spill of light, to really know how to differentiate a good light from a bad light. One very famous example is looking at this metric of PPE, which is essentially the efficiency of transforming the watts into photons in the photosynthetic range, and the density of those photons in the photosynthetic range, which are the lumens. And so the theoretical max on LEDs is 5.8 micromoles per joule per second. And I could make a light, Bob comes up, he uses this example all the time. I could make an exclusively green LED that could be 5.1. And you wouldn't want to grow with that. I mean, that's certainly higher than our harvester is 2.5, and it's an industry leading light, but that's not the best metric that anyone might cite. They might cite 3.2 or 3.4, but you have to account for what spectrum of light is being delivered within that range. That's the real meat and potatoes, if you will. So yeah, I mean, I understand that's how science is going, is, trying to compact everything down into one number that we can assess everything all at once. And you really have to gauge a number of variables.
Is there any way to integrate under the curve and sort of let you add it up and average out what's coming?
Well,
I mean, in the sense that, a photon of blue light is not going to, is going to have a different energy level than a photon of red light.
Right. So what I would say is, okay, we have this PP measurement, and let's say we're comparing a value of 2.5 versus 3.0, which could make a substantial difference. Now it's going to come down to what spectrum of light are we delivering for this measurement. And if we find out, okay, this one here has a full spectrum with all of the colors, which the plants require for their metabolism, all their cellular processes, and maybe that's the 2.5, which is that's the harvester, versus the 3.0, but maybe it's only red and blue, or maybe it's missing green, or maybe it's missing ambers or the reds. Well, then that's going to be an inferior technology. You're going to have an inferior result. So, and I understand it from a sales perspective. People want to make this as simple as possible, but the science of photobiology, horticultural biology, particularly in the cannabis space, I mean, we're just scratching the surface here, and so it's a pretty comprehensive process, multivariate process that we have to evaluate in terms of valuing the efficacy of this light.
Well, it sounds almost like in the marketing speak, you're talking about they advertise horsepower in cars, and horsepower does not translate 1-to-1 in how fast you can go in that car.
Yeah,
Exactly.
that's a comparable analogy, certainly. But and again, it just goes back to the marketing. And I think in this particular sector, you certainly see a lot more marketing than you see science. And from our perspective, it's not as though we're trying to take an against the grain approach. It's just that I'm not a salesperson, I'm a scientist. Bob's not a salesperson, he's an engineer. So we don't really have a way to attack this with marketing. We're coming at this with science. And so far, that seems to be a very healthy approach.
Excellent. One of the things that also, as Zach has already alluded to, is the frequency that you're putting out in the light. So Bob, well, why is it important to have a full spectrum of lights?
Well, the science is there. There are so many studies that give you the benefits of a certain spectrum of light. Greens for aesthetics and taste and flavor, and in food crops, and ambers in certain other development, and far reds when it comes to photoperiodism, and the near red. 660 nanometer red for flower. And as an example, Dr. David Gates published a paper a while back that, and I don't mean a while back like 100 years, I mean like 15, 20 years ago, that he actually quantified the number of photons it takes in each part of the spectrum to process a CO2 molecule in a plant, photosynthesis. And he came up with 1 to 2 blue photons or 8 to 10 red photons. That gives you an idea of how to quantify that. And it's going to change. I mean, we don't know everything. Just as an example, in 2012, and I apologize, we're going to have to give these people credit for this, but another chlorophyll F was found, which is chlorophyll A antenna pigment. And they found it in 2012, and probably the reason they didn't find it, it's outside the visual range. We didn't know, and we still don't. If you look at what the sun delivers to the earth and what plants have been basically evolved to use over time, it's everywhere from 200 nanometers, which is way down in the UVC range, maybe even 180, all the way up to 2000, which is microwave, is delivered through our atmosphere, with some exceptions that our atmosphere blocks, but very, very minor blockages. But so we've got a lot to learn.
Excellent. Well, let's talk about the manufacture of the LED. So it's like, what's involved in making an LED and getting it onto a board and into a light fixture?
Wow. It's actually a very straightforward process now. It's a solid state device. In the case of white LEDs, there are many ways to make a white LEDs, but with the exception of what we call a blue pumped phosphor diode, which is basically a blue LED. You put a phosphor over it that's excited by the certain frequency of blue, and it gives you your, for all intents and purposes, a broad spectrum or a full spectrum output. There are other ways to create white LEDs, and it could be, and everybody that as old as I am knows what a red, blue, green gun is, because that's what was in our TVs. So you've got a red, a blue, and a green, very specific, very narrow band, and you pump those out towards the human eye in various quantities, and it appears to the human eye as white. Well, that's not how plants see things. Plants see the whole spectrum plus some. And so as far as white LEDs go, we use a blue pump phosphor, and created by our long-term manufacturer, a specific phosphor that we've actually developed over about the last 7 or 8 years that we've been allowed to develop our own phosphor. Then we supplement it with some very narrowband discrete LEDs to pump up certain functions such as flowering and chemical composition, so phytochemical responses in the plant. Of course, also we do use some far red to help with the photoperiodism and other photomorphological processes.
But when the plants are in their vegetative or the flowering stage, are they still using the entire spectrum in those two distinct stages of the plant's life?
Yes, they are. Now, you're going to see more in the vegetative state. They're going to be using more of the blues and the greens. And that's generally why you see some folks using ceramic metal halide in the veg phase. And then you're going to see greater utilization of red in the flowering phase. So you see some folks, start with ceramic metal halide, then switch over to HPS. Whereas if you have a full spectrum alternative, such as full spectrum LEDs, you don't need to switch the lights. They will do absolutely everything. So, and there's like Bob said, there's a lot going on in between there. The various colors, adding flavor, adding phytochemical content, and we can get into this in much greater detail later on in the show. But I mean, we're looking to unearth some of that knowledge in terms of how some of these genetics respond through.
Let's just go ahead and talk about it right now. I mean, that sounds like something that's important. So you're telling me that you've got a way to actually amplify other things besides THC and CBD, which the industry is finding out is actually important. The terpenes, the flavonoids, carotenoids.
Yeah. So I'll just touch in there, and then Bob can chime in. So we've got this study where we've got our full spectrum LEDs as controls, and then we also have some experimental tents where we're oscillating red light frequencies to manipulate the phytochromes, which play a central role in various cellular processes. And what's really quite amazing here is we've partnered up with some fantastic groups. So we're partnering with Shimatsu. We have their instrumentation to do all the cannabinoid analysis. We partnered with Nanova Environmental, and they have a mobile GC unit, which is an absolute game changer for the cannabis and hemp sector. So instead of collecting a sample of your flower material, taking to a laboratory and waiting a couple of days for analysis, we're actually measuring terpene volatilization in real time, which is obviously reflective of what the terpenes are producing in the trichomes. And in addition to that, we're looking at flavonoids. A lot of people have been talking about flavonoids. Flavonoids are generally represented as color pigments. So for example, you have the anthocyanins in blueberries, blackberries, very powerful antioxidants. You have the carotenoids you mentioned. So carotenoids are responsible for the pink flavor, or the pink color in flamingos. They eat these little small shrimp that are loaded with carotenoids. They become pink. Beta carotene, for example, that's what gives carrots their orange color. And so it's kind of a new class of constituents that people are really starting to understand. The terpenes and cannabinoids, they're represented in the extracellular trichome glands, those little glass bulbs that give the flower the frosty appearance, versus the flavonoids, they're present more in the vegetative matter, So it's a much different analysis. And so we're trying to understand how can we push these different equilibriums to enhance expression of certain classes and maybe attenuate the expression of other classes with different frequencies of light. And the most recent development here, which we're quite excited about, pertains to these anthocyanins that you can see represented in the flower with these dark purple and blue colors. Generally, anthocyanins are triggered by drops in temperature. So anyone growing cannabis outdoors, you hear about Croptober in the Pacific Northwest. Well, the final 2 weeks prior to harvest, those plants start to get this beautiful purple and bluish color because of the drop in temperature at night. And so what we know is that certain, the anthocyanins, for example, will respond to blue light frequencies. But what we've recently come to realize here is that our oscillation of the red light frequencies actually appears to have triggered a significant upregulation of anthocyanin expression. So again, we're just kind of scratching the surface. We have all kinds of ideas to put in supplemental bulbs. We're really kind of interested in helping folks create cannabis strains of all different colors. So, I mean, you've got your standard green, dark green, and then now we've got some of these purple, blue varietals, and maybe we can help push the expression of more of the ambers, the oranges, the reds. So it's pretty exciting.
Oh, that does sound exciting. Just for comparison, I mean, can somebody do the same with metal halide high pressure sodium lights? I mean, if you were to do a side-by-side grow comparison, could they do the same?
Yeah, theoretically, sure. It certainly is possible. You have to look at the spectrum. I think with the LEDs, I kind of look at them as like little Legos. I mean, if you look at the board, which is above my head here, right? It kind of lends itself to being a little bit more customizable. So from my perspective, I mean, if we wanted to integrate more blue light frequencies to pull out anthocyanin production, probably easier to do on an LED board than ceramic metal halide.
Excellent. Bob, anything you can add in?
Yeah, I just want to add to that. LEDs allow you to introduce very, very narrow band specific frequencies, sometimes only 2 or 3 nanometers wide, which of course looks better in a scientific review. But yes, I'm with Zach as far as the phytochrome study that we're doing right now. Very exciting. My excitement is everything Zach's excited about, but I'm also excited that we're finding, if you look at the documentation that Zach's been posting, especially the last snap of he did a heat map representation of the 4 test plots. In the control, we're getting some tremendous terpene expression in the 1,000-watt control. And that lends itself to suggest that it's a power issue. And it could be other things, but that's the thing I'm going to look at first in that particular plot. So yeah, we're finding out a lot about this, and it just goes to show you, like we started out saying, we're just scratching the surface.
Well, it almost sounds like eventually you're going to be able to tune for each particular phytochrome and get. I mean, is that what you think the end point is?
Ultimately, where I think that this research is going is trying to understand how far you can get with your genetic limitations of a particular cultivar, and then how far you can push it with altering some of the environmental variables. And of course, there's all kinds of genetics out in the world, and a lot of them are kind of homogenous, and they're a hodgepodge of, I mixed this with that because I thought it would give it a cool name. And so we're very fortunate in the fact that, we're collaborating with guys like Adam Jacques and Chris West, Oriah Love, Matt Spurlock, Andy Grosella. So these guys have been creating very unique genetics for decades, both in the cannabis and the hemp space. And so it's kind of a treasure trove. If you want to start with unique genetics, this is a great place to start. And then, of course, I have the supreme pleasure of working side by side with Bob. And so if it's like, hey, I want to try these experimental conditions, can we configure a light to do this? He finds a way. So it's really the best of both worlds. And then again, when you couple that with the fact that now we've opened up this Pandora's box in terms of the flavonoid analysis, I've had quite a bit of feedback on LinkedIn, and it sounds like there's a couple commercial labs that are doing this, but the flavonoids are really hard to get to because they're in the plant material. You have to strip away a lot of the waxes and the fats. And so you have to use a number of different solvents. It's not just like your cannabinoid analysis where you throw your flour in some methanol and boom, 5 minutes later, you're ready to go into your HPLC. So we're developing a lot of novel methods there so that now once we have hundreds of different samples under different environmental conditions, we can run them as a large kind of meta analysis, very similar to a pharmaceutical approach, with small molecule targeting.
Excellent. Let's talk about how much it costs to go to LEDs, because one of the things that seems to be an impediment are capital costs. And I've read that lighting accounts for up to 60, maybe even more percent of the capital cost. So what can you tell me, Bob?
Yeah, LEDs, yes, they're more expensive, but really what's important is for somebody, especially starting out and has to make that choice between high pressure sodium or ceramic metal halide and LEDs, what's your return on investment going to be? I mean, after all, cannabis used to be about growing weed. Now it's a business, and it's a legitimate business in most states. And you got to look at your numbers. You got to look at your bottom line. So when we have LEDs, yes, we have a higher capital cost, but within oftentimes between 15 and 18 months, you get your break even as opposed to high pressure sodium. And that break even is facilitated by the savings in power. And this is not even counting your yields or what you're going to make in your crops. But as far as yield and power savings, HVAC savings, your ROI is relatively short. Now, if you want to talk about, and this is where I'm going to defer to Zach, but if you want to talk about phytochemical responses and the quality of cannabis you get out of LEDs versus high pressure sodium, it's no secret that LED actually is producing as good or better cannabis than high pressure sodium and even ceramic metal halide. I heard, it's a little pedestrian, I apologize, but I have a friend who is a police sergeant down in Florida, and he said, I could always tell when I pulled over a car moving large quantities of cannabis that what was grown under LEDs and what was grown under high pressure sodium. And I said, yeah. I said, how? He said, just the smell. And so, of course, that's a terpene production issue. So yeah, it's it may be more costly, but in the end, if we were to take that ROI and start putting the yield increases into it, and of course the phytochemical response and terpene production into it, then we're talking almost always top shelf product, and we're talking bigger yields, and that's what sells, especially in these states where, well, look at Oklahoma, almost 7,000 cultivators, so that's a huge competition out there. You've got to have top shelf, or you're not going to sell your stuff unless you're going to sell it for biomass.
Yeah, and just to add on that, I'll quote our friends up in Canada with the company Peace Canna, in that they said, shortcuts equal pay cuts. And that means, if you're going to use an inferior lighting technology because you want to reduce your initial capital costs, well, you're going to produce inferior product and you're not going to get the yield. And so I've had this conversation with many folks over the last couple of weeks. I mean, traditional technologies, you may be quite satisfied with a 1 gram per watt yield and a flower material that has 22% cannabinoids and maybe 1.5% total terpenes. Well, a lot of our clients in Oklahoma are producing 30% cannabinoid flower with up to 4% total terpenes. And so, and they're getting up to 2 grams per watt. So clearly you're doubling your yield, and it has a higher phytochemical content. So not only do you have more material, but now instead of selling your flower for 2,200 a pound, maybe you're selling it for 3,500 a pound. So Bob's absolutely right. I mean, with all that competition, there's certainly a race to become more craft and more connoisseur in that particular industry. And then I think where it's going now, once we have the analytical methods in the peer-reviewed literature and they become adopted in commercial laboratories, the next play is going to be the flavonoids. We're going to want to know, okay, great cannabinoid profile, great terpene profile, but tell me about what flavonoids are expressed in this particular strain. And that might be a differentiator. So that's why we're doing a lot of these studies, messing around with supplemental color to see if we can really push the equilibrium in terms of different flavonoid expressions.
Now, one of the things I've been reading about is the deterioration that happens with use and age with all the various types of lighting. How does LED compare to metal halide and high pressure sodium in that regard?
Well, first of all, the two different lighting technologies are measured differently. They have different metrics. When you generally speak of a high pressure sodium or ceramic metal halide or metal halide bulb, you speak about the number of hours it survives until it's out, till it's dark. And no longer produces any light at all. Whereas LEDs have always been held to a much higher standard. Lab testing for LEDs, you test sometimes real time, sometimes accelerated testing. Obviously, for some of the newer LEDs, you can't do real time because I don't think I'm going to live that long. But LEDs are tested to 70% of the output or 90% of the output now, especially for horticultural work. So there are LEDs out there that it's called an L90 test. So they estimate the number of hours that LED will last until it's only producing 90% of its original output. And it's very common now to find LEDs out there that have an L90 rating of 36 to 50,000 hours.
Wow.
Well, at 12 hours a day, 50,000 hours is how many years, Zach? It's a lot, right? 10 years or so.
It's about 11 years.
Yeah, so 11 years, no lamps, no ballasts, and the power supplies also have a similar rating. So it's 10 years not having to replace your lighting equipment until we come up with something new.
Yeah.
Okay. Well, is the power consumption by an LED the same as high pressure sodium metal halide?
Consumption? No. Go ahead, Zach.
So this is where you get into one of those kind of anecdotes you may have heard where you might hear 600 watts of LED is equivalent to 1,000 watts of high pressure sodium. And that's absolutely true because of the inefficiency in production of waste heat. So nearly 90%, if not more in some cases, of the watts that are utilized are generated into heat. Versus the LED in which there's only about a 70% loss in some cases. And that's absolutely substantial. Bob can get into more of the engineering, but as far as heat production, LEDs certainly do produce some heat, but not nearly as much as the HPS.
Now, do LEDs require mitigation strategies to get rid of the heat?
Yeah, absolutely. LEDs are far from not heat producing. You hear all the time, oh, LEDs don't get hot. Well, they absolutely do. But how we mitigate that heat is to connect it to certain materials that wick the heat away from the LED and put it out the backside, usually through a heat sink of some sorts. And then we run a fan across it, and then you use your normal evacuation techniques to get the air out of the space. So that means there's no heat on the plant side of the LED as long as you're removing the heat from the back side of the LED. So it's pretty straightforward.
Okay, well, I think we've pretty well covered the basics. Is there anything else that you want to bring up that you think is important?
Wow. Yeah, there's a lot of stuff.
Well, then let's cover it. So that's why we're here.
Well, I'm lead me by the nose, Ed. So
Okay.
I mean, the one thing that I'll say again is for the folks there looking to get into cultivation, looking to expand their operation and to really maximize their ROI, considering that lighting comprises 60% of capital expenditures, it's in your best interest to really get that dialed in. And quite frankly, that is the largest determining factor of whether your grow is going to be successful or not, whether the lighting works. And so I think people need to ask a lot of questions. Again, just distilling it down to one particular metric is not comprehensive enough. Certainly is a nice guide, but I think a lot more people need to ask about the spectrum. They need to ask about how the light penetrates into the crop. What about the lenses? That sort of thing. I'd love to hear more of those questions as opposed to just getting inundated with what's your PPE, what's your PPFD, what's your PAR value. You know, even something like CCT, right? The color corrected temperature. You know, this is a measure of how human eye perceives color, not how plants.
Not the plants.
Yeah, and so we even see some of that metric. So again, we're kind of coming at it from the perspective of I'm not trying to find some metric that fits my narrative so I can have some confirmation bias to sell you some lights that you may or may not like. I'm here to talk to you about cutting edge science that we used to make what we believe are industry leading lights. And we want you to have a massive success with these lights. I mean, there's nothing that makes us happier. I just heard from a buddy of mine, Dr. Matt Spurlock in Drain, Oregon yesterday, and he was blown away at how his harvesters were performing and just ordered some more. So that's what we want to hear. We want to see people having continued success. I want to share, yield results, and I want to share cannabinoid and terpene profiles with all these people. And we kind of have like an internal competition with if you will, because people say, hey, I just pulled down this amazing yield and I got this cannabinoid value. Have you ever seen that before? And I can go back and say, yep, I just saw that. And our buddies in Alaska beat you on that one. So it's very friendly competition that we have, but it's great to see so many people having success. And that's really what's the most rewarding aspect of this.
Excellent. Well, I'm out of questions right now. So, we've covered the stuff we said we were going to talk about. As far as I'm concerned, we can wrap up unless you.
So what do
I do. Go ahead, Zach. I'd like to say the questions we've been receiving, we get questions all the time, of course, and they're along the lines of what Zach's already alluded to. But one thing I get asked all the time, why did you build your light the way you did? And I just wanted to reiterate, because I think I said it last episode, that we originally built lights like everybody else did. When the stuff was coming out of China, really nobody knew what they were doing, and they were using old 100-year-old studies to develop spectrum, and we did the reds and the blues, and we just realized, we're not getting anywhere else. We've got to be able to do better than this. I'm looking at plants being grown outdoors that are upwards of 30 pounds. Why can't we do that? And what do we need to do that? And so the light is based upon science that, just went and read through hundreds of peer-reviewed papers and scientific papers on spectrum and effects on plants, and some of the stuff way over my head. And thank goodness I have Zach to save me in that regard. He explains to me in my layman's terms what I'm looking at. But the bottom line is we use science to come up with a baseline. And then since then, we continue to follow the science and we continue to change based on the science. But we also, and this is the big thing, we also look at what everybody else is doing and what the shortfalls of those designs are. And we try to correct some of those shortfalls, and such as no penetration. LED lights are known for not having the penetration that high pressure sodium does. Why? Why? Sheer power. When you take a spider type light and you put low wattage LEDs spread out over the entire distance, you get zero penetration. You'll see a lot of these companies will say, oh, put your lights at 6 inches above the top of the plants. But back to the inverse square law for light, if you were to move that light to 12 inches, you'd lose 75% of your light output at your crop. I don't know of any grower that wants to change their light height by an inch every single day. They have other stuff to do. So we built to counter that. We built to counter the flower issue. We built to counter the light collection and distribution issue, power supplies. Everything we do and everything we will do is to correct things that we see wrong in accordance with the science that we're seeing at the time.
So, I mean, that sounds like a pretty large list of things that you've done that are different from other people. So,
yeah,
Well,
quite a few.
that's why Bob is he's the guru, and I'm the guy with the polysyllabic words, and he's Batman, I'm Robin. We're trying to and save the world from inferior lighting technologies.
Yeah. I think he's more Alfred. He's making sure that he's making sure I don't screw up.
I guess I do have another thing to talk about is that considering the startup cost, does Curtis Mathis have any programs that don't require me to plunk down hundreds of thousands of dollars all at once?
Yeah, we absolutely do. Worked out a deal with a leasing company to represent us and white label a leasing package. Up to $5 million we can finance.
That's a lot of lights.
It's a lot of lights. Yeah, it is. It's and we have quite a few customers taking advantage of that. And we'd like more. It does solve one of the issues. So in addition to altering our lights to correct a lot of the things wrong in the industry, we also realize that there are people out there that let's look at cannabis from a cultivation standpoint. Realistically, it's paycheck to paycheck, but not every day. It's paycheck to paycheck every 4 months. So when people harvest their crops, that's not always the case, but it's pretty often that it is the case. So if you were to have some way to finance your lights, then that would take that cash flow load off of you.
Excellent. So I take it traditional banks don't do this type of financing?
They don't. And you do have some entities that will provide leasing on cannabis related equipment at 25% interest, which seems rather predatory.
Wow.
So our lease is 5% interest, make payments over 3 years, lease to own. And so as Bob just alluded to, I mean, we're trying to reduce the initial capital expenditures to help make these lights more accessible. And so far it's been very well received.
Wow, that's a huge difference.
Yep.
Massive.
Yes.
Mm-hmm.
Because it all comes down to, I heard this adage at a conference once, and some guy asked me, do you know how much cannabis was consumed in the United States?
All of it.
I'm like Alan from The Hangover trying to do this complex mind, and he just said, all of it. Because this is the new frontier of medicine. People are going to find a way to, when whatever is grown, it's going to go as flour, or it's going to be transformed into edibles or some other, modality to get this medicine out there. And so all of this medicine that's being produced is consumed. So if you can make the game, so to speak, the cultivation game, more inclusive, more accessible to those that maybe don't have wads of cash or blue chip investors behind them, then that's rewarding, because I think there's a lot of young talent in this industry that wants to stake their claim. They want to do innovative things. They want to create their own strains. They want to differentiate themselves. And so, we take a tremendous amount of pride by being able to open up the doors for those people and allow them to get in the space and utilize the best lighting technology. So to kind of really accelerate their growth.
Well, I mean, it sounds like using the lighting technology, you could actually use the lights to bring out, those parts of the plant that actually do produce a medicinal value. And in my mind, that would command a price premium, once you're trying to sell it.
We're seeing that in the phytochrome study. If you again look at the last heat map study that Zach put out, we're actually manipulating for very specific terpene profiles using light only. Each one of those plots is getting the same food, same temperature, same water. With the only variable is the light. It's supposed to be. So I just hope those guys are watching. But yeah, so I mean, who knows? Maybe someday somebody will say, "Hey, I want you to produce this Gorilla Glue number 4, but I want you to make it really heavy in linalool." Okay, and I don't know if GG4 is heavy in linalool, but whatever the case may be, and we'll say, "Yeah, we have a spectrum for that. We can make that happen."
So, and to build on that, Ed, as a physician, I mean, you see this as the new frontier of medicine, but because it's a Schedule I drug, there's been so many restrictions on the research, particularly with the cannabinoids. Now, when it comes to the flavonoids and the terpenes, well, these molecules are ubiquitous in our environment and have been heavily studied in other plants. And we know what those molecules do. We know that the flavonoids are powerful antioxidants, which play a central role in human physiology. So yes, are we working towards taking tailored strains and then altering the environment?
Yes. Yeah.
Those features? Yes. Because in this field of medicine, again, it's a new frontier. We're in the nascent stages. I mean, we're that blob, crawling out of the primordial ooze, and we're just starting for legs, right? In terms of evolution. But for people that are using traditional pharmaceutical medicine and they want to go into something more holistic with less side effects and try cannabis, they cannot afford to have a negative experience their first time. So when they go to someone and they say, "I need something for acid reflux," or "I need something for pain," or "I need something to help me sleep," they're often met with someone that is just trying to sell them some product based on an anecdote that they heard from someone. "Oh, this Gorilla Glue number 4 or the Northern Lights that we have is great for sleep." Well, just based on the name alone, or because you don't know the provenance of that strain, how it was grown, who crossed it with what, you need to know what's in there. It's based on what compounds are present in that strain. So it's all based on data. And so if we just work backwards and we find out, okay, these terpenes are for sleep, these terpenes are invigorating, these flavonoids help with anti-aging. And so if someone says, "I want an anti-aging strain that helps me, that invigorates me before I work out," well, we know what compounds in terms of terpenes and flavonoids can do that for them. So let's find a protocol to be able to pull those out naturally. And so that's what we're ultimately working on, because I want to see the day before I die where someone says, "I have this specific condition. I need a strain tailor-made for me." I think we will get there. We're quite a ways away, but we're certainly making progress in that direction.
Well, one of the things I want to point out is that even in Western medicine, every one of our medicines has come from an original plant source, insect source, or an animal source. It's not like they just went and cooked something up in a lab de novo. They started out with a molecule that was produced by nature. It may have been greatly altered to make it useful in a human, but they came from a source that came out of nature.
Yeah.
Yep.
Yeah.
Absolutely.
where this field is going to go once it becomes legalized at the federal level. I have to imagine the pharmaceutical industry is going to take that similar approach. I mean, this is just another plant that they were able to extract natural compounds and thus make derivatives thereof. So yeah, we believe that we're certainly one step ahead of them because, again, they have the federal restrictions and we're operating at the state level. So we're trying to unearth as much of this new knowledge as we possibly can. But what we're really learning, and I mean, we don't appreciate it enough at times, is just how important the light is. And just to elaborate on Bob's point there, I mean, what we're finding under the higher full spectrum lighting is that there's a larger, more diverse bouquet of terpene. Whereas when we oscillate some of the red light, we're actually seeing the expression of of other terpenes. So, there might only be 2 or 3, but they're of different species. And so, again, very fortunate. I just want to shout out to the folks at Nanova Environmental. I mean, none of that research, we wouldn't have been able to have this new knowledge without their technology, their mobile GC. So it's been a really exciting time, and look forward to continuing to share this new knowledge with as many folks that'll listen.
Now, one of the things also in Western medicine is they've, tried to take it down so that you're only doing one molecule at a time. And in cannabis medicine, there seems to be the entourage effect where it's actually multiple molecules combined and they're synergistic in their effects. What can you say about that?
So we know that when you isolate THC or you make synthetic THC, I believe the drug is Marinol, and this is by GW Pharmaceuticals. And they had all kinds of side effects like nausea.
Used it.
Yeah, it's, I mean, I've never used it myself, but.
I mean, not professionally, I don't mean personally, so.
Sure. So you look at that data compared to folks that are using kind of a full spectrum approach, right? With all the flavonoids, the other ancillary cannabinoids and the terpenes, and it's a much more well-rounded approach. I mean, Dr. Ethan Russo has really been a pioneer on characterizing the specific entourage effects between individual cannabinoids and specific terpenes, which is to say that, hey, if you take this cannabinoid that's for inflammation and you take this terpene that's helping with, let's say, blood sugar regulation, but you put them together, now all of a sudden you've improved some other aspect, some other physiological pathway. So really quite phenomenal stuff. And I mean, again, just kind of scratching the surface. At least one thing that we're doing is we're trying to comprehensively characterize all of the natural constituents that we can. And then obviously, ultimately looking to, downstream here to work with more of the medical community to understand what some of those constituents are doing in a human context.
Yeah. Well, that's certainly where the research is going to be going. When you look at the studies that you can do for pain or nausea, and you look at it from what parts of the brain, are involved, what we're finding is that our old thoughts that it was basically a unifocal area of the brain for nausea or pain is absolutely wrong. Now, there's 2 well-known areas that affect pain and nausea. But when you study somebody that's nauseated and see what parts of their brain light up, multiple areas light up, and it's the same thing for pain. And I've got to imagine that once we can start studying, beyond, where does CBD and THC go in the brain, but some of these flavonoids and carotenoids, and, are they neurologically active? And I think we're going to find out that some of them are.
You're probably right. Yeah.
Well, that took a turn we didn't see, guys.
That was interesting.
But yeah, I mean, that's certainly why I'm excited by all of this, because it's like, it's like you're saying you want to see it before you die. Let me tell you, I really want to see it before I die, because I'm a little older than you. So.
Well, it looks like you're going to be a part of it.
Okay, good. So we'll work on that anti-aging thing first and the Alzheimer's thing, and then I'm good to go. So.
The ED strain.
Yeah, well, then we have ED medicines, but for something else. So,
Yeah, yeah.
well, it's, speaking of which, I've read that cannabis and sex sort of go together. I mean, it's like, is that true?
Yeah, well, a number of the compounds are vasodilators. And so obviously that's an important part of male and female performance, is dilation and vasodilation of those regions. And so,
Hmm.
yeah, the two go very much hand in hand.
I mean, are there any particular strains that have been noted to be better in that area than others?
Oh boy, that I don't know. Quite again, it comes
It
down to
sounds like there's some research that needs to be done. So,
yeah, certainly, but I mean, it likely comes down to chemical content, and I don't know if there has been a study looking at that particular medical application again because of the restrictions. I believe some of the terpenes are also vasodilators. A lot of them are bronchodilators, opening up your alveoli, things like alpha beta pinene. But again, there's so many research opportunities here because of the restrictions. It's pretty much wide open.
I mean, is there any anecdotal evidence out there for use in like erectile dysfunction? Sort of like a Viagra type use.
Um, Without saying some rather crude things, yeah, I mean, you hear the occasional anecdote. I haven't really documented those too well to know if there's any patterns there, but they do exist. I mean, people do share their experiences with them. And I also, from my understanding, the delivery mechanism also has an incredible role in differentiating whether you get the desired effect. I mean, that's an entirely different show as well, looking at smoking and the absorption in the lungs versus the absorption in the cheeks versus the digestion and the conversion from delta 9 to delta 11 in the digestive system versus suppositories, which people laugh about. But for people and in terminal states, when they need to get 250, 300 milligrams of THC into their system, well, they certainly can't go through the mouth or smoke that much. I mean, the suppository is the way to go, which essentially circumvents certain metabolic pathways.
Yeah, we use that quite a bit with opiates, especially as you're saying, hospice care, things like that.
Yep, it's a very nice vascular membrane there, so very good for absorption. So again, the science here is quite fascinating on all fronts, and so that's what kind of keeps us going here is asking these kind of questions and learning new things each day.
Excellent. Well, I think we can start wrapping up now. So let's go around the horn here, and we'll start with Bob. Any last words?
Yeah, I can't follow up on the ED thing, but but no, I really don't. I did want to make a shout out, Joe. If you're watching, thank you for watching, and I appreciate you. And but there are a lot of people that may be watching. We don't have a console right now that we can actually. I don't have a console that I can tell who's on and who's not. So, but thank you, and that's what I've got.
Zach?
No, I've made a number of shout outs here, and a lot of the research wouldn't be possible without our collaborators. Shimatsu Corporation, Zed Therapeutics, Nanova Environmental, University of Texas at El Paso, University of Texas at Arlington, and all the wonderful people that we've worked with. It's this particular research and the work that I've done here, just speaking personally at Curtis Mathis, has been very rewarding because I get phone calls where people call and share their positive experiences. And it's unlike anything I've ever seen before. So just hope to meet more people in the future and help them expedite their growth.
Excellent. Well, just to finish up with our audience, we're going to be meeting some of those people in a future episode. So we're going to be bringing them in for their testimonials and what they found. And you can get it straight from the horse's mouth and not just the salespeople, which would be me. We'll also be talking about financing options. That'll be our last episode. And we're going to go through how to choose and set up your LED lighting in our next go round, which will be in a couple of weeks. So anyway, that's it for today from Curtis Mathis Grow Lights. We hope you've gained some knowledge, and we'll look forward to seeing you in 2 weeks.
Yeah, thank you, Ed.
Thank you, everyone.